Okay, and today we're going to talk about inverse functions, but before we get there, we need to develop some tools to be able to use to describe inverse functions. So the first tool that we need is a special property called the one-to-one property. And this is if we take any two x values, if they result in the same y value, then they are not one-to-one. So in other words, if I look at, say, going to look at this green graph. I'm going to look at let's say I look at 2 and actually 2 is a bad example. Let's look at 1 and negative 1. Okay. At negative 1, or at positive 1, we're at, let's call that negative 7. And at negative 1, we're also roughly at negative 7. So that means we have two x values that correspond to the same y value. So this function does not have a one-to-one property. Whereas in this one, if I looking at the red curve, I say let's take negative 1 and pick negative and 4. I can pick any x values that I want, and I'll always get different y values. Now graphically, this is really easy to see if we do what is called the horizontal line test. So if I take my horizontal line here and pass it through the function, if it hits more than two places on a function, then it is not going to be one-to-one. And you can see here it fails. Now going through the red one, I go through all the y values and it passes the vertical line test or the horizontal line test. And similarly here, the blue curve fails because we hit we have three x values where the y value is the same. Okay. If it passes the horizontal line test, then it means it has the one-to-one property. If it fails, it doesn't. And if a function is one-to-one, then it does have an inverse function. An inverse we denote as f with a superscript of -1. Keep in mind this does not mean this is not equal to 1 over f, which would be the reciprocal function. Inverse function and reciprocal functions are very, very different. So do not think of the superscript as an exponent. We have some very properties of inverse functions, and well, I'll talk about this in a minute. But inverse functions have to be one-to-one. When we do this, inverse functions also have the property that the domain of the original goes to the range of the inverse, and then the range of the original becomes the domain of the inverse. So if we just make a little chart here to help us visualize this process, f and f inverse, and I'm looking at the domain and the range for both of these, we're saying that the domain of f goes to the range of the inverse, and the range goes to the domain of the inverse. Okay. If I do the composition in either order, I'll get back x, or what is known as the identity function. Okay. And then graphically, the function and its inverse are symmetric about the line y is equal to x. And also, in obtaining the graph, all we have to do to obtain the graph of the other function, if we are looking for f or its inverse, is to switch the coordinates switch the x and y coordinates. Okay. Now, one skill that we're going to work on in particular with inverses is finding an inverse function. We first have to decide if an inverse function exists, or what would make an inverse function exist, which we'll see in the example below. But then we have this process that we will go through as well. Okay, so in our example, we want to determine the inverse function of f, and the domain and range of the inverse function, and the original function is given here. Now remember, if I take a horizontal line, it has to pass a horizontal line test. Well, right now it fails because it hits for two different x values, I have the same y value. Okay, so that's not good. But what I'm going to do is I'm going to restrict the domain. So I'm going to add a condition here. I'm going to say x is going to have to be less than or equal to, and I'm going to go, this is a quadratic, I'm going to go from the left side of the vertex, so less than 1. Okay, I'm going to add that condition in. Okay, so this is saying, this is already giving me the domain of my original function of f. Okay, but let's go ahead and walk through this process. So I set f of x is equal to y. That's already been done for us. Second step, and this is the step that is the most algebra, we want to solve for x in terms of y. So I want to get x alone. So I go through algebra. I do y minus 3 is equal to minus 2 parentheses x minus 1 squared. Okay, continuing of a y minus 3 over minus 2 is equal to x minus 1 squared. Okay, I have to square root both sides. When I do a square root, remember I have a plus and minus. Y minus 3 over minus 2 is equal to x minus 1. And now I am going to pick one of these signs, but I'll do that in just a moment. And then solve for x, I get 1 plus or minus the square root of y minus 3 over minus 2 is equal to x. Now up until now I have done nothing but algebra. I haven't changed anything. Now I have to keep in mind my condition that I'm being given here when x is less than 1. Now in order to get x being less than 1, I need to choose the minus sign. Why? Because I have 1 plus or minus a value, and this value, a square root value, I don't care what it is, but the output, I don't care what it is underneath as long as it's a positive number, but the output of a square root function is always a positive number. So I need to be able to subtract a positive value. So I'm going to choose 1 minus the square root of y minus 3 over minus 2 is equal to x. Okay, so I solve for x. Good, and now I need to do my third step, which is to switch x and y. So I'll have, and I'm going to rewrite this as y is equal to 1 minus the square root of x minus 3 over minus 2. And then lastly I replace y with f of x, or f inverse of x is equal to 1 minus the square root of x minus 3 over minus 2. Okay. And then the last thing that I need to do is to determine the domain and range. The domain and the range. Well, I'm being given that the domain of the inverse is x is less than 1. So that's actually the range of the inverse. So that's negative infinity to a positive 1. Okay, and now for the domain, I need to see, well, what kind of values can I input into here? Well, I certainly need, if I have a square root, I need x minus 3 over minus 2. That needs to be a positive value, that or equal to 0. So I go ahead and solve this, and I'm just going to get x is greater than or equal to 3. Okay, so my domain is going to be a minimum of, and I actually forgot one little thing here, is I'd have to multiply by a minus 2, and that would actually switch my sign. So it's actually x is less than or equal to minus 3, or equal to 3. So my domain here is, let's see, it'll be negative infinity comma 3 with a bracket, and I am done. This is one of the more intricate inverse problems that you'll see. A lot of them you won't have to determine the domain. It may be given to you, or it might be easier to find. And then keep in mind too, if we wanted to, we could also show the inverse graphically. Okay, and that's a quick tutorial on inverse functions.